All right, we're going to go and do something, just a quick little review, how to multiply what's called the difference of squares. This is going to be important when we get into our quadratics. All right, so first of all, what I'd like you to do is understand if you have a quadratic, you will have it usually equal to a 0, okay? Sometimes, eventually, you're going to have to set it equal to 0. Right now, I want you to understand what we're actually looking for. So after you factor things, when you're looking for zeros, you're looking for like what numbers would you plug in there to make it equal to 0. So for example, I could plug in a -3 and that would make it equal to 0. I'd plug in a +3 and that would make it equal to 0. So my solution set, if they were asking for what are the solutions of this quadratic, it would be at -3 and +3. And that's called a solution set. Now, it's not asking us to do that right now. I want to make sure you guys know how to multiply things together so eventually you know how to factor them. Okay? So these are called factored. This is a factored trinomial. All right? Actually, it'll end up becoming a binomial. So here we go. First thing I want you to do is we're going to do it the box method, and then we'll show you the shortcut for a difference of squares. Now, we're starting our quadratic section, but this is kind of like an intro to our quadratic section. So we have x, and we have a +3, and I have an x and a -3. So when we do it this array method, x times x is x squared, x times -3 is -3x, 3 times x is 3x, and 3 times -3 is -9. Now, in a difference of squares, one thing you will always notice is these will always add together to equal 0. And all you're left with is x squared minus 9. So the shortcut is just do the first terms and the last terms, because in the FOIL method, these will always add together to equal 0. So you just need to focus on the product of the first terms and the product of the last terms. Okay? Now, if you're wondering what I was talking about in quadratics, I want to make sure you are clear on that. So check this out. Let me go to my Desmos real quick. So look what happens when you guys type in parentheses x plus 3 and then x minus 3. Do you see where the zeros are? The zeros are at -3 and +3. So when we set this equal to 0, those are the zeros, and that's what we kind of talked about at the beginning. All right. So right now, I'm just going to type in x squared minus x squared minus 9. Okay, now this one right here, it's a little bit trickier, but we're not going to do a whole bunch with it. We're just going to focus on what multiplying the first terms and the last terms. That's the shortcut. 3 times 3 is 9. 4 times -4 is -16. X times x is x squared. Now, they didn't say write it in standard form. In standard form, I'd have to write it as -16x squared plus 9. These are the same, but it didn't say we had to write it in standard form. So this one, I didn't do the array method because I know these will eventually add to 0, so I'm just doing it the shortcut. All right? So 9 minus 16x squared. There we go. Now, if you're wondering, wait a second, how would I find the 0 of this guy? All right, it's pretty easy. We're not doing it just yet, but we will get to this. You might have a question like this, and it'll be, what are the zeros of this? So if I set this equal to 0, and then somebody asks you, what are the zeros? You literally have to set this equal to 0, and then you'd have to set this equal to 0. What does that mean? 3 plus 4x equals 0. And over here, we'd have to say 3 minus 4x equals 0. And then we have to solve for x. Minus 3 from both sides. 4x equals -3. Divide both sides by 4, and you get -3/4. Over here, we could add 4x to both sides. Add 4x to both sides. We get 3 equals 4x, divide both sides by 4, and we get +3/4. All right, so what would be my solution set? -3/4 and +3/4. Now, some of you might be saying, man, I wish there was a shortcut for that too. There is. It's always the negative version of, hold on, did I mess up? No. Oh, when you have it this way, 4x plus 3, then I have to rearrange it and put negative 4x plus 3. It's always the negative version of this over this. So this was the negative 3/4. The negative version of this over this, that's negative 3 over a negative 4. That would become a positive 3/4. So you have to range it where the x values are up front. All right. The tried and true method is always just set these equal to 0. But whenever you have it set up like this, you always take the negative version of this number and just place it over the first number if the x's are up front. All right. Now the next part we need to work on is multiplying perfect squares of binomials. Now this one, my suggestion is this: simply use the box method, okay, or the array method, just to make sure. So on this one, make the box, if I can. Nope, almost there. Just fast forward eventually. Eventually, good. Okay. Now, this one actually means 7x minus 1 times 7x minus 1. So we have to put 7x minus 1, 7x minus 1. And then once again, we just multiply things out. 7 times 7 is 49. X times x is x squared. This is a negative 7x. This is another negative 7x. Negative times negative is a positive. What you'll notice when you're doing this one is these will always be the same terms. We've got to add those together. So our final answer is 49x squared minus 14x plus 1. That's going to be my final answer. Now, there are two perfect square binomial products, okay? The first one will be a squared plus 2ab plus b squared. This one is always a squared minus 2 times ab plus b squared. If you're wondering where you get the 2, because it's always double these. Think about it. Negative 7 plus negative 7 is the same as 2 times negative 7. All right? So these right here is what you'd probably see, say, in Google or a textbook. That's what they would say if you're dealing with this concept called perfect squares of binomials. All right, but this is going to be our answer. All right, so we got 49x squared minus 14x and then plus a 1. All right, so this one, I'll just do one more and I'll call it a day. It's very, very, very easy. The first one was a little bit harder because you actually had to kind of figure out what to put in the box. This is pretty much self-explanatory. You got to put a what? An x and a minus 10 and an x and a minus 10. X times x is x squared. X times negative 10 is negative 10x. We got another negative 10x and we got a positive 100. You see how this is going to be double it? Right? You double that, you got x squared minus 20x plus 100. Now, honestly, here's the shortest shortcut, all right? What's negative 10 plus negative 10? Negative 20. What's negative 10 times negative 10? 100. So when I'm looking at these, a lot of time, all I'm doing is doing x squared, negative 10 plus negative 10 is negative 20, negative 10 times negative 10 is 100. Now that will work if and only if the number that's in front of the x squared is a 1. Otherwise, if it's not, you better do the array method. Okay? X squared minus 20x plus 100. All right? This one's another easy one. I won't show you the method because it's super easy. It's just x squared. What's 6 plus 6, everybody? 6 plus 6 is 12, right? So it plus 12x. What's 6 times 6? 36. See, that's pretty super easy. This one, we'd have to do a little bit of the box method, right? Okay, so this will be the last one I do. We'll call it a day. I thought you just said that. Now, if I did the shortcut, like in my head, this is what I do in my head, and so you can see if it makes sense or doesn't make sense. Come on, dude, seriously. All right, so here's what I do. 2x times 2x is 4x squared. What's 2 times 3? 2 times 3 is 6. Double that is 12. And what's 3 times 3? 9. So that's what I do in my head because I'm thinking of a squared plus double a times b plus b squared. So I've done that so many times. But you don't have to do it the shortcut. You could literally do it this way every single time for accuracy. Okay? Just remember, accuracy is much more important than speed. This plus this is 12. And there's our answer. 4x squared plus 12x plus 9. Now, how did I do this again? 2 times 2 is 4. What's 2 times 3? 6. What's double that? 12. And 3 times 3 is 9. Have a good day.